my name's Jorge Rodriguez. I'm with BloomReach. And we make pretty heavy use of Spot Instances to run our pipelines, various pipelines. In this case, we're going to be talking mostly about our ETL processing. So, at BloomReach, we've achieved high levels of throughput with low latency by using Spot Instances and by optimizing bidding strategies, and I'll talk a bit about all those things. So we'll start with telling you guys a little bit about our company. Then I'll talk about the goals of our infrastructure and what we're aiming to do, and then some of the challenges that we face because we use a lot of Spot Instances. And then I'll go into our infrastructure, both the Qubole side, where we do the Qubole as a service, as a Hadoop MapReduce service, and some in-house technology that we built, which is called we call it the Bloomstore Compute Cloud. It's built on the Elastic Compute Cloud. All right, and now I'll take some questions for you guys. So BloomReach, we built a personalized discovery platform. It features applications that analyze big data, makes our customers' digital content more discoverable, relevant, and profitable. I'm a tech lead on our data platform team, and basically I'm in charge of running our multi-regional Cassandra database, scaling on the backend for the backend pipelines, and our real-time data processing infrastructure. So a little bit more about BloomReach. So basically have 3 lines of products. The first line is about customer acquisition. The second one is about customer experience. And the last one is about content marketing and merchandising. So our customer acquisition is essentially enhanced discoverability, improved organic search, and basically content management and content optimization on our customers' websites. Our Snap product is a search navigation and personalization platform. So it's a search as a service on the cloud, and our Compass product is a marketing tool. So essentially it's like site analytics, analyzing user behavior, making recommendations on how you should improve your website. And we run all of our infrastructure on AWS. All right, so some of the goals of our ETL infrastructure in particular is, we really need to process our customers' data fast. So we receive a lot of product feeds from our customers, and we need to reflect the latest information very quickly and basically across all of our products, especially the site navigation and personalization product. We really need to achieve in-order feed processing, so we receive delta feeds from our customers, sometimes every hour, sometimes every half hour, sometimes every 6 hours, basically however often they want to feed us their data. And then we produce the data and we replicate it to a production serving infrastructure. So most important thing for us is linear scalability. We have right now about 125 customers, and we're hopefully trying to grow that very fast. So every time we bring in new customers, we really want to onboard them onto our system really quickly. We don't really want to be expanding our main infrastructure, on-demand infrastructure, every time we're trying to bring in 1 or 2 maybe larger customers. So we find that we can get the maximum processing capacity for our budget, and Spot Instances in general, we found that it give us about 10 times the resources for the same price. So what is the challenge of AWS? This is basically, Mike kind of touched on that quite a bit. They can be reclaimed by AWS at any time. So when we first started, we didn't even have the 2-minute warning. It just, you're running something and all of a sudden you're not running it anymore. Fluctuations in spot prices, they can affect costs quite a bit. And also you want to be careful with hard coding instance types and putting in high bid prices to make sure your instance is not reclaimed, because you actually wind up paying more. If your bid price exceeds the on-demand price, I think Amazon will be glad to charge you more than the on-demand price.
Yeah, spot price can absolutely be more expensive than on-demand.
Yeah.
That's probably what you should choose on-demand.
It's kind of, you kind of shoot yourself in the foot if you're bidding more than the on-demand price. Right? If you're going to bid that much, launch on-demand.
You pay always your bid price?
No, you pay whatever the market price is.
You pay the market price for spot at that time.
Right.
Okay. And the instance will be terminated if the market price goes above your max that you set. So I think what you're suggesting is don't set the max too high.
Exactly. Yeah. Don't go overboard on your max, because.
You will set the price of a normal instance, right?
But it can still be reclaimed by AWS at any time. So now you don't have the unreliability of Spot, and you're paying the price of on-demand. So it doesn't necessarily make as much sense. It makes sense when you're saving money, or when you're getting much higher throughput for the same amount of money, which is really what we're trying to achieve. Right? All right, so I'll go with like a little bit of a high level of our ETL infrastructure. And we actually use this very similar infrastructure across many of our teams. A lot of backend pipelines that use this kind of infrastructure. So for the ETL, we have FTP servers. Our customers will upload their files into FTP servers. We have a polling client on those servers that will then launch our ETL jobs. And the ETL jobs are running on Qubole, which is Qubole's Hadoop as a service. And they depend on something that we built in-house, which I mentioned is called the BloomStore Compute Cloud. And the BloomStore Compute Cloud basically is an API, and you tell it, I need this data, and I need these solar collections. Please launch me a cluster. And so what we'll do is we'll on the fly launch you a cluster that will either have solar, Cassandra, or both. We actually expanded for our real-time streaming applications. We expanded to installing Spark and installing Kafka and some other technologies as well. But for the most part, most of our jobs right now, they're depending on Cassandra and solar. So what happens is the job will run. It will create whatever data needs to be created on these Spot clusters, BC2 clusters, which are running on Spot. And then it'll promote that data to the production infrastructure. So our production infrastructure is the Cassandra as a data store and solar for searching, right? And we run all of our infrastructure on AWS, and we run across different regions. But all of our back-end pipelines are running in the East region right now. Front end, we're in the West, in the East, we're in the EU, and we just recently expanded to OPAC. All right, so the Hadoop part of this, where we're showing the ETL, Qubole runs on the Qubole data service, which is on EC2. The biggest feature that we benefit from on Qubole is the autoscaling. It's really awesome how it works. It's really saved us a lot of time and effort. And what you do is you set up a Hadoop cluster and you tell it how much Spot utilization do you want and how much on-demand utilization do you want. For all of our production jobs, we're right now running at about 90% Spot and 10% on demand. So basically our master nodes run on demand and some worker nodes as well. And for staging and dev pipelines, we're running 100% on Spot. Another benefit of Qubole is whenever you get a job, it gets kicked off right away and it starts to run, and the cluster will expand or contract depending on what workload you're giving it. There's a lot of user interface that we get from Qubole. We get a lot of job success failure tracking, and this is both as in visual interfaces, and we also get APIs which we can use to automate our tracking. It's got simplified log access, and even when your instances are taken away, for the most part, you get your logs persisted, which is really useful when you're trying to debug. Did you have a question, Jeremy? Okay. So this has really reduced our operational overhead. And then one other nice feature that we like on Qubole is the fact that it provides us with the ganglia metrics. We have a manager on our team who is all about utilization. So he'll come by and he'll check out your metrics, and if you got some free memory, if you got some free CPU, you better get on that. You better be using less instances, and you better maximizing utilization on those instances. He one time told me that if you're stealing some resources from a neighbor VM, you're doing a great job and you deserve a raise. All right, so some of the numbers for our ETL pipelines, we're running about 1,000 plus jobs per day. We're processing over 40 million products into our infrastructure. The number is much larger when you look at SKUs versus products, like different iterations of a product, but a little bit harder to get the number. And the job runtime in general is between 10 to 20 minutes for each of these jobs. There's a couple of outliers, customers that have really large data or a really large number of products. The Spot instance failure rate that we're experiencing is about 2 over a 24-hour period. So for our use case, that's actually just about 4%. But the nice thing about Qubole is that even when Spot instances are reclaimed, your job doesn't necessarily have to fail, right? Because it'll just spawn a new Spot instance and your job will continue running. All right, so then on to BloomStore Compute Cloud. So this is elastic infrastructure that we run on AWS. As I mentioned, we will provision a Cassandra solar cluster on the fly, and it will replicate whatever data you requested to that cluster. It supports both Spot and on-demand instances. Mostly we use Spot. I would say like 99% of the time we'll use Spot. There's some very rare cases where if a job will fail 2 times, then the 3rd time we're going to go to on-demand because we got to make sure that it succeeds quickly. We don't want to let too much time run by, so we'll take the hit. And it's a create, use, terminate model. So you'll create the cluster, you'll run your pipelines on it. When you're done, you'll publish your data to whichever place you want. For the most part, it's going to be your production infrastructure. And then when that's done, you'll terminate your instances. So this is all the things that we built in-house. What is the technology behind it? Mainly it's cluster management. It's dynamic cluster provisioning and resource allocation. It allocates instances according to requirements and costs. So Mike was talking about building a model based on spot price history and what the current market is. And I'll go a little bit more into detail into our optimal bidder in a second. Another thing that we do is we pool instances, and this is actually something that's both helped in terms of speed. The jobs will obviously run faster if you don't have to wait the 5 to 7 minutes of provisioning time. You get reliability because we found that AWS has been very reliable for us, but I would say the least reliable piece for us has been the APIs. So the provisioning and deprovisioning APIs. We've had a couple issues over the last 6 months. We've had, well, 2, which is not necessarily that much, but if you're really relying on that API, then that can actually kind of hurt you. And neither of those were necessarily too long, but for us, even an hour is kind of long. And so what we do is when a job is finished and it's done using an instance, we'll reclaim it and we'll put it back into a pool. And depending on the demand, we might terminate it once the hour is up. So as Mike mentioned, you pay for, in AWS, you pay for an hour, right? And so if an instance has ran for an hour and 5 minutes, then it doesn't necessarily make sense to terminate it, because if they reclaim it, yeah, you won't have to pay for those 5 minutes. But if you're the one terminating the instance, well, now you're paying for 2 hours, right? And you just lost 55 minutes of processing time on that instance. So what we'll do is we'll put that instance back into a pool, and when the next job comes in, we'll reuse that instance for whatever we need to use it for. So that saves us money, gives us additional reliability, because even when the AWS APIs go down, if they do, you can provision instances, but the instances that you were already provisioned, they're fine. And in fact, the spot prices are going down, right? Because nobody can provision. So if you're keeping your instances around, then you're making use of them and you're saving money. So in fact, take it down whenever you want, guys. We're good with that.
I don't know if I like this.
And then the other 2 pieces of technology essentially are data management technology, right? So we have a solar haft API, which essentially manages solar data. It can replicate from one solar cluster to another. It can do verifications on the data sanity. It can do data integrity checks. And you actually use this for a production infrastructure as well. It's an open source project. If you guys check out our blog post, there's a really cool blog post on the solar haft technology, and maybe even useful for some people. And then the other one is a Cassandra replication service. So even though Solar does have a replication API which you can use, which was really handy, we had to build around it a little bit. On the Cassandra side, there really was no replication technology we could use. So we went ahead and we built our own. And it's been working fairly well for us. All right, so our optimal bidder, the way that our optimal bidder works is just a simple API. You tell it what requirements you want. So if you got to tell your disk requirements. Do you need an SSD, or are you okay with a spinning disk? How much storage do you need for each particular individual node? How much storage do you need for the whole cluster together? Same with the memory, right? How much memory do you need per node, and how much memory minimum do you need for the entire cluster? And then again with the cores, how much processing power you need per node and per cluster. And then the optimization function, you can specify whether you want to optimize on the CPU per dollar cost, or if you want to optimize on the memory per dollar cost. And internally, what the optimal bidder is doing is basically exactly what Mike said you should do if you want to use spot instances in a large scale. It's just building a model, is looking at the history of the spot prices, and it's trying to make intelligent decisions about how much am I willing to pay for this instance. And then obviously the output of the bidder is which instance type you should get, how many instances of it you should get, which availability zone, because the prices will vary depending on the availability zone, and how much the current spot price is, like what is it going for right now, and what you should bid. And always take into account what is the on-demand cost. Don't bid more than the on-demand cost. And the BC2 also came for us with a lot of additional benefits. One of the biggest ones is if you think of like your Cassandra cluster or your Solar index, right? It's a very fixed resource. Especially on the Cassandra side, it's really hard to scale up and scale down a Cassandra cluster when you have a lot of data in it. For us, in our use case, if we want to add a node to our Cassandra cluster, it takes us 6 hours, right? So we launch it and it starts to join. It'll take 6 hours before that node is running. So if you're working on like a peak workload and a back-end load, you really don't have 6 hours. By the time the 6 hours have passed, you already miss your SLA, and you got upset customers. That's never a good thing. So isolation is really a good benefit. Pipelines get their own cluster; they cannot interrupt each other. We don't have one team arguing with another about how their scans are, making their lookups run a lot slower. It's a multi-tenant, multi-application support. So we have various teams. We have, I think, 7 teams now at BloomReach, and all 7 teams are actually using our BC2 infrastructure. We use it for not just for running these backend jobs. We actually use it for dev purposes too. So developers wants to do some experimentation on Solar or Cassandra. Well, they'll go into our API and they'll launch a cluster and they will replicate the data that we already have, whatever data they want, and they can start to kind of experiment, run their analytics, run their pipelines. It's really good for a developer use case. Sometimes they're a little bit annoyed, like if the instance does get taken away. But we've done a good enough job with our bidding that rarely happens. It provides dynamic scaling, so each pipeline can define its replication load and requirements. So for example, on a Cassandra pipeline, if you're doing a lot of scans, you're going to need a lot of CPU, basically, is what we found, especially if you're scanning large amount of data. The disk I/O on the SSDs is really fast, but the CPU is actually really important as well. It's a production safeguard because there's no direct access to our production backend. It safeguards from bad clients and access patterns. When we first got started about 3 years ago, we used to have a lot of issues with developers kind of getting a little crazy. Maybe they were putting too many nodes into their EMR job, and next thing we know, we were getting paged left and right because they're hitting our backend clusters way too hard, and things are crashing. So this actually really helped us to safeguard the backend from clients. And right now, we really don't have any direct access to our production infrastructure from the backend, only from front-end applications. And again, we're saving on costs because we're provisioning Spot instances. We're trying to be smart about how we bid for the Spot instances. And this saves us a lot of money, gives us a lot more compute power for the same cost. And it keeps our margins nice. When you're a startup, that's always a nice focus to have. So some stats on our BC2 infrastructure. Right now we're running about up to 250 Solar Cassandra clusters per hour. This is across multiple teams, not just the ETL infrastructure. Our Spot instance failure rate on most days will be between 0 to 5 Spot instances will get reclaimed for the whole day. And our worst day, I took a look for this presentation at the last month, what was our worst day. And our worst day, we lost 85 Spot instances for the entire day. So it's about 3.5 per hour. And if you're considering that we're launching 250 clusters per hour, that's a fairly low rate of instances getting taken away from us. So we're getting the benefit of the lower cost, and we're not really paying a price in losing out on instances. And the nice thing about Spot instances is I think that even if there's a lot more the Spot fleet, is something that's going to bring a lot more users to the market. But I actually think that's probably going to be even better because AWS always has to stay ahead of the demand, right? And so even if there is more Spot usage, I really feel like AWS is going to keep up and keep launching infrastructure so that we can continue to use it, or at least I hope. But if they don't, we can always fall back to on-demand, and it'll hurt our pockets, but our stuff is still going to run just the same. We're processing about 40 million documents per day for the ETL pipeline, and across all of our teams, about 160 million documents per day. All right, so in conclusion, you can find ways to work around the unreliability of the Spot instances. It's going to take some experimentation. It's going to take some work, and it's going to take some solving of the problems. Building your pricing model is going to take you some time, but in the end, it's really going to be worth it because you're going to save a lot of money. You're going to get a lot more done for a lot less money, and that's something that that's going to help your company in the long term. So you build this tooling, you build it one time. You may make some improvements, iterative improvements here and there, but in the long term, you're going to save a lot of money. One second. We have some good blog posts about this subject and about our production infrastructure, both Cassandra and Solar, on our engineering blog. So I'd encourage, if you're interested, to take a look at that. We're hiring, so it's obligatory recruitment. If I didn't put that in there, I'd get in trouble with the recruiting team. And feel free to reach out to me. My email is jorge@bloomreach.com.